Let's talk about dimensional formula of some physical quantities. Okay, this is a very important question topic. The first is what? Area. Area is equal to what? Length into breadth. So length is L and breadth is also L. So what? That is L square. Okay, so we can write this like this: m to the power 0, L to the power 2 and t to the power 0. This is the dimension of area. Okay, now dimension of volume. That is length to breadth into height. Length is L, breadth is L, height is L. So that is L cube. So we can write m to the power 0, L to the power 3, 0. This is the dimension of volume. Now next, density. That is mass upon volume. Volume unit is dimension is this, so we can write m upon volume is L cube. So that is m minus q t. This is the dimension of density. Velocity. What? Velocity. Distance by time. Distance is L, time is t. So that is m to the power 0, L t minus 1. Okay, now next, acceleration. dv by dt, and velocity dimension is ये. This is m L t minus 1 and time dimension is t. So this is m to the power 0, L t minus 2. This is the dimension of acceleration. Now talk about force. force is m into a. M and acceleration is this. So dimension of force is ml t minus 2. This is a dimension of force. Dimension of force. Work. Force into displacement. Force, this is m l t minus 2 and displacement is l, so dimension of work is ml square t minus 2. Okay, now since we know that work is energy and energy is work, so the dimension of energy will be same, m l square t minus 2. If we talk about any kind of energy like heat energy, potential energy, kinetic energy, every energy has a dimension is this. Okay, you don't have to confuse, you don't have any confusion. Okay, now momentum. Momentum is m into v, mass into velocity. Mass m, velocity is lt minus 1, so that is ml t minus 1. Impulse. Impulse is equal to force into time. Force dimension has m l t minus 2 and time is t, so that is ml t minus 1. Now torque. F into R. Okay, torque is F into R. The dimension of force is ml t minus 2 and R the dimension is L, so that is m l square t minus 2. Now next is pressure. Pressure is force upon area. force is ml t minus 2 ml t minus 2 and area is L square. So that is m L minus 1 t minus 2. Now power. Work upon time. Work is force into displacement. So ml t minus 2, displacement is L and time is t. So that is m L square t minus 3. Okay, now next, angle. Angle is arc upon radius. So arc is also L and radius is also L. So that is m L L0 T0. So this is a dimensionless. Okay, angular velocity. L naught on t. So that is t minus 1. So we can write m, this is the angular velocity. Now next, moment of inertia. M into r square. This is m and that is L square. So that is m L square t 0. Okay, now next, angular momentum. Angular momentum is equal to I into ओमेगा. ठीक है, एंगुलर वेलोसिटी. सो I is m L square t and omega is t minus 1. So that is L square t minus 1. Frequency equal to 1 upon t. So 1 upon t. So m L t minus 1. Now next, stress. Stress. This is ml t minus 2 upon area. So that is m l minus 1 t minus 2. Strength. Strength has a no dimension. ठीक है. Modulus of elasticity. Modulus of elasticity. That is stress upon strength so strength has no dimension, and so that is m l minus 1 t minus 2, and that is m naught l naught t naught. So dimension is m l minus 1 t minus 2. Okay. Next, one thing you have to keep in your mind, what? Young modulus Young's modulus bulk modulus and modulus of rigidity. Modulus of rigidity has dimension same. Okay. Now surface tension. Force upon length fourth is ml t minus 2 upon l, so that is m l naught t minus 2. Okay. coefficient of viscosity, coefficient of viscosity बहुत important है, this is very important. इसका फॉर्मूला होता है विस्कोसिटी स्ट्रेस, विस्कोसिटी स्ट्रेस अपॉन फोर्स upon distance. So and it has a dimension is like this is force upon area हो जाएगा ये, it will be force upon area, so ml t minus 2 upon L square, and this is also force upon this is a ml minus 1 t minus 1. Now next g, gravitational constant, gravitational constant, gravitational constant. How will you, since we know that F equal to G m1 m2 by r square by the formula, so G equal to F into r upon m1 m2. The dimension of force is ml t minus 2 and r is L square and m, and this is also m, so 1 is cancelled out, so that is m, so ठीक है, L cube t minus 2. Gravitational potential, gravitational potential equal to gravitational potential energy upon mass. So आपको मैंने बताया था एनी काइंड ऑफ एनर्जी which will be same dimension, so that is m L square t minus 2 upon m. So that is m naught L square T minus 2. Okay, now we discuss some heat related now specific heat. H equal to ms delta T, तो S equal to H upon m delta T. S is specific heat and this is heat, so the dimension of heat is same because it is a part of energy, it's a types of energy, so that is here, and this is mass and it is theta. Okay, so that is m naught L square T minus 2 theta to power minus 1. This is a dimension of specific heat. Now thermal capacity. Thermal capacity is equal to mass into specific heat. Mass m and specific heat is m square T minus 2 theta to the power minus 1. So that is m square T minus 2 theta to the power minus 1. Latent heat. Latent heat is Q is equal to ml, so L equal to Q by m. Q की डायमेंशन हीट एनर्जी है आपकी, तो यही होगी ml स्क्वायर T minus 2 and this is mass, so dimension is mm cancel out, so it is m naught L square T minus 2. Planck constant. H equal to energy upon frequency. So that is energy is m L square T minus 2 and the dimension of frequency is, I have already told you, T minus 1. So that is m L square T minus 1. Boltzmann constant. K is equal to energy upon temperature. Energy is dimension ml square T minus 2 or temperature is theta. So that is m l square T minus 2 theta to the power minus 1. Coefficient of thermal conductivity. Coefficient of conductivity. Q is equal to Ka theta 1 minus theta 2 into T by X by the formula. So here K is Q into X upon A into theta 1 minus theta 2 into T. So K is, that is energy, so that is m l square T minus 2, that is distance L, that is area, so L square, that is temperature, so that is theta, and that is time, so that is T. Okay, so what we will get? We will get, after solving this, m l T minus 3 theta to the power minus 1. Now thermal resistance is theta upon m l square T minus 2 upon T. So that is m 1 l minus 2 T 3 theta. Okay, universal gas constant. Universal gas constant. So R is equal to PV by T. So P is m l minus 1 T minus 2 is, that is L cube, and T is theta and mole. So the dimension is m square t minus 2 theta minus 1 mole minus 1. Okay. Now next, charge equal to IT. I is A, T is T. So M L T A. Electric potential W by Q. So W is a work, and work is M L square T minus 2, and Q is M L T A. So solving this, we will get what? M L square T minus 3 A minus 1. Resistance V upon I. V is M L square T minus 3 A to the power minus 1, and I is A. So we get M L square T minus 3 A to the power minus 2. Capacitance Q equal to CV. So C equal to Q by V, and Q is 80 and V is M L square T minus 3 8 minus 1. So it is M minus 1 L minus 2 T 4 and A is square. Now inductance So student, it is enough for your, this is a third lecture. In next lecture we will discuss the uses of dimensional analysis. Okay. Thank you.